Back in on example 3, where we left off yesterday, right?
Yes.
So, talking about cost, marginal cost, revenue, profit, all this fun stuff. The cost of producing a set of Bluetooth headphones is given by the production manager as C of X. Find the marginal cost function, then use this function to estimate how fast the cost is going up if the company produces 100 sets of headphones. So, how do I find the marginal cost function? Derivative, right? So one of the things we learned yesterday, MC is going to be C prime of X. Well, this actually says find the marginal cost function. So we can't put this part into the calculator because your calculator won't give you the function. Make sense? So, what is the derivative here?
50 plus 0.02x.
Okay, so yeah, since it's asking me to find the function, it's not something I can put in the calculator. Then it says, use this function to estimate how fast the cost is going up if the company produces 100 sets of headphones. So now what am I doing?
100 per x.
Yeah, I'm plugging in 100. So at this point, we've already found the equation, so I would probably just do it by hand, because 2 hundredths times 100 is going to be 2, plus the 50 is going to make it 52. That was going to be my question. 52 what?
$.
And this is dollars. This is $52 per headphone, set of headphones, however you want to say it. Okay. Compare your result from part A to the exact cost of producing the 101st set of Bluetooth headphones. How do we find the exact cost? Into what equation? The original. Okay, so to find the exact cost, you're going to do the cost of the 101st headphone, and then you're going to have to subtract off the cost of the 100th headphone, yes? And that is going to give you, the cost of the 101st. Now at this point, could you type in your original equation into y1 and do it that way? By all means, you could. Give me some numbers.
1500 plus 50x.
Switch over. Not that I have to show this one on the calculator, but there'll be things today I may need to show on the calculator. So 1500 plus 50x plus 100th x squared. I have that in my y1. So like we showed yesterday, you can do y1 parentheses, and I'm actually going to find the two values. So there's y1 evaluate at 101. And I'm going to find, why did I just pick y2? I'm going to find y1 evaluate at 100. And then you're going to take those two values and subtract them. Or maybe you just put it all in your calculator as one, right? That works too. So what do we have here? We had 6652.01 minus 6600. When we subtract that, we're going to get 5201. Yep. That's a pretty good estimate to be off by a penny. Okay, C. Find the average cost function, C bar, and evaluate C bar of 100. Explain the meaning and context to the scenario. Okay, so flip back to yesterday if you need to. How do we find C bar?
CX.
Okay, it is doing C of x divided by x. Now, to find the actual function, because it actually says find the function before we evaluate it, yes? So this is like, okay, can you give what that function is? So that means, let's see, what was C of x? That was
66.
now, okay, guys, listen, you're not, they want the function.
1500.
So they want the function of variables before we ever plug 100 in. Okay? Yes, we're going to plug 100 in, and yes, if I was plugging 100 in, I'd just do this on my calculator right now. But they asked for a function. So this is going to be the 1500 plus 50x plus 100th x squared. That's C of x, right? Divided by x. Can that be cleaned up a little bit? If it's divided by x, just a single term, each of those three terms on top can be divided by x. There's only one that doesn't clean up nicely. 1500 divided by x is going to be 1500 over x, or 1500 x to negative 1 if you want. I was just going to do that. 50x divided by x. X is canceled, it's 50. Plus 100th x squared divided by x. That's your 100th x. Right there is your average cost function they asked for. Now, evaluating at 100, yeah, plug in 100. So 1500 divided by 100 plus 50 plus 100th times 100. Challenge yourself. This is doable without a calculator. And I know you guys all hate me for saying that, but when I divide 1500 by 100, I cancel zeros. So 15 plus 500. Why did that become a 500? Okay. 15 plus 50 plus, what's 100th of 100?
$1.
1. So 15 plus 50 plus 1 is 66. Okay. And officially, this is average cost function, right? So $66, like we said earlier, per headphone or per headphone set. Okay. Explain the meaning and context. What are we saying here? $66 per headphone set when? When
it costs 100.
when we're producing 100, right? So is it always 66 per?
No.
No, not necessarily. But this one is, so when we talk about the average cost function, this is when, because we plugged in 100, when 100 headphones are produced, the average cost is $66 per set. So when 100 headphones are produced, the average cost is $66 per set. Okay. That was an easy one to start a day, right? At least I felt like it was an easy one. Okay, 4. Bless you. Here's the Okay. Suppose those new Bluetooth headphones from example 3 sold for $125. Wow, price increase here. Okay. Write the revenue function.
Let's use the prescriptions.
R that equals total revenue received from sales of X.
Or X.
Not that type of RX. Okay. RX is total revenue received for the sale of the X units. So if,
100.
huh? Well, we're not just writing the function, so don't plug any values in. So how much are we going to receive if we sell X units?
125.
125 each time you sell one, right?
Yeah.
So
125x.
125x. You're overthinking it, right?
I'm trying to do my work here, Marco. I'm trying and it's not working.
Okay, so the revenue function is just, if it's selling for $125, each time you sell one, you get $125. It's revenue. We're not talking profit, just the money coming in, right? Now, speaking of profit.
P equals X minus C.
What'd you say now?
P equals R of X minus C.
Yes, except for profit, we're not supposed to be using P.
Pi.
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 Oh,
So pi of X is equal to R of X minus C of X. To me, that's logical. I hope that's logical to you guys as seniors, that profit is found by taking the revenue, how much you bring in, and subtracting off your cost, right? Okay, now, I want more than that, though.
well,
What do we already know?
C of X is this.
Okay, C of X, do we have it from the other page? Yeah, what's R of X?
That up there.
That up there? Okay. So we're going to have, now, watch how I set this up, 125x minus, we're subtracting that whole other function, yes? So we're going to be subtracting
100 plus 50 x 50x.
plus 1/100th squared, if I recall. Okay. Not that you have to clean it up, but it's a good time for me to talk about it. If we clean this up,
75x.
okay? So, realizing we're subtracting everything from that cost function, yes?
Oh.
So, I'm going to put it in either standard form or reverse standard form. In other words, I'm going to put my minus 1500 first, if you don't mind. 125x minus 50x is going to be a positive 75x, and then you are subtracting 1/100th squared, and that is your profit function. Okay?
That would be reverse standard form, right?
Yeah, that's reverse standard form. And did I have to write in this form? No, it just seemed weird for me to put the 75x first and then have the other two. So I either wanted standard form or reverse standard form, one or the other. Since cost was what I would call reverse standard form. Yeah. Okay. Yep. Marginal revenue function is going to be the derivative of revenue, so R prime of X. R prime of X is?
125.
Man, tough derivative there.
I know.
Did we all get that?
Sweating.
If only all of our tests were a derivative test, and that was the derivative, right? Okay, D. Compute the marginal profit if 100 sets of headphones are produced and sold. Interpret your findings. Marginal profit.
Between B and then
What'd you say?
the derivative of B.
The derivative, I couldn't hear you. Derivative of,
B.
did you say B?
Part B.
Part B.
Part B, okay.
Sorry.
I'm like, where's she getting B from? Thank you. Okay, I'm there. Okay, the derivative of our profit function. I was really confused. You're fine.
It makes sense.
And it totally makes sense now that it's pointed out to me. It wasn't clicking, okay? Okay, so yeah, marginal profit, that's going to be the derivative of the profit function. Now, it kind of works out that we did go ahead and clean it up, doesn't it? Because that makes my derivative a little easier. What's that derivative of profit up here?
15.5 minus 0.01. Or 0.2.
Sorry.
I'm going to go for derivative of negative 1500 is Zippo. Derivative of 75x is 75. Minus the derivative of 100th x squared is going to be 200th x. Okay. They asked us to compute the marginal profit if 100 sets. So what's that mean? Pi prime of 100. So, yep. Ends up being 75 minus 2, which is 73. What did Doug say?
73 buckaroos.
Buckaroos. Okay. So $73.
Per head.
Okay. Yeah, so interpret your findings here. Compute the marginal profit if 100 sets of headphones are produced and sold. So
Oh, at a rate?
it is a derivative, so we have to throw rate in there. We should throw rate in there somehow, right? So this is when 100 sets of headphones are produced and sold, because to find profit, they have to, they have to be produced, they have to be sold. Then what is it that's happening here? What's increasing? Profit. The profit is increasing at a rate, $73
Per 100?
per
Set.
set.
Oh.
Per set. The per 100 type thing goes more back to the inverse. And we had to throw that in. Okay. So, when 100 sets of headphones are produced and sold, the profit is increasing because it's positive, right? Increasing at a rate of $73 per, I just wrote per set, per headphone set, per whatever. You guys are,
We're in a fight.
what's new?
Because you're wrong.
Okay. E. How many headphones should the company produce in order to maximize their profits?
More than 100.
Definitely more than 100.
I have no idea.
Does
that mean, is this when
These
we
keep
plug
producing
it
and
in?
maximize their profits.
No, because at some point you would start reducing your profits because you would flood the market and they wouldn't be bought anymore.
Because you have
So-
surplus violence.
There we go. Surplus. There's the word. Throw in these econ words for me. You know.
8.2 billion because you can sell one to every person in the world.
Okay. So maximizing profits.
But it doesn't tell you what the
You need to set an equation equal to
what
something,
the demand is.
right?
Okay, we're setting the equation equal to something. Correct.
I can't, I want to say 100,
It doesn't tell you what they're
but
what the
it's
demand
not
is.
100.
Well, okay. So what is this most recent equation we have?
Are we supposed to set it equal to the revenue?
I think we need to look at a supply and demand graph
Yeah.
We.
so we can see.
Okay. We're not doing that in calculus today. Okay.
Dang.
So what we want to do is we want to set we have the marginal profit formula there, and we are going to set equal to 0. Okay.
I'm stupid.
We are trying to get. We're trying to get to where that rate. How do I want to say this? I just, oh my gosh, we've talked about 100 so much that I just wrote 100 instead of 0. Okay? So we're looking to get that marginal profit equal to 0. Now, what is our marginal profit formula?
75 minus 102.
75 minus the 200's x equals 0. So 200's x equals 75. 75, well, they're either both negative or in my brain I just went ahead and made them both positive. Officially, if you keep this negative, then you subtract that over, they're both negative, but
You could also
add the 200's x over. They're the same sign.
Okay.
And so when you divide them here, we're going to get positive.
Thank you.
We're going to think you're contagious. 3750.
Like, I'm just waiting for an answer here. Okay, so we've got the 3,750. And that is the amount the company should produce to maximize their profit.
Oh.
So profit is maximized when pi prime of x equals 0. And the company should produce 3,750 sets of headphones, however you want to label. Okay.
Like, logically, how does that make sense? So it's easier for me to remember to set. Are you trying to make as much money as you would have, like the number you would have had to subtract to find the profit? That didn't make sense, but I just want to understand.
No, I get it.
Equal to 0.
And I'm trying to figure out
Because we're trying
how do
to
I put
find
this in
X.
words. So we're trying to maximize profit, and the derivative of profit is the rate that it's changing.
Mhm.
Trying to think. Do we want to think if profit is maximized, does that mean profit is no longer increasing? There we go. Okay. I'm trying to get there in my brain so I can put it, So here's what I'm thinking. Up here, our profit was increasing at a rate of $73, right? So when we set that derivative equal to 0, our profit is no longer increasing, but it's also not
Decreasing. That's
decreasing.
the 0, but it's not increasing or decreasing.
Yes.
Okay. That makes sense.
Okay.
Cool.
Sorry, I had to get there in my head too.
Yeah. Mhm.
How can I put this the best way?
Okay, that makes
Okay.
sense.
Are we good?
Now,
Okay. We have a pretty picture to look at before we turn the page. Okay. As we talk about, we've talked about some of this other stuff already. Okay. So, in the graph shown at the right, notice the break-even point occurs where the revenue equals the cost. Okay, so you've probably heard the word break-even points, yes?
Mm-hmm.
You're seeing there where revenue, which, by the way, we have a revenue function, we have a cost function, where they equal. Those are your break-even points. Break-even when, we're not losing money, but we're not making money yet, right? We're not earning a profit yet. Let's see, what else do we want to point out here? Profit is going to be in that section above. Loss is going to be before and after those points, right? let's see. A company would obviously be most interested to know how to maximize profits. The maximum or minimum profit can occur where marginal cost equals marginal revenue. Or in other words, C prime equals R prime. Maximum or minimum profits do not necessarily have to occur, though. They can also occur at endpoints. Consider the slopes of the tangent lines. Then when the marginal cost is less than the marginal revenue, a company will make more in extra revenue than it will spend in extra cost by increasing production. So, slopes of so marginal cost, well, the slope of that line is always going to be right here, isn't it? Because this is cost. When we talk marginal revenue, well, here we've got all these different slopes, right? We've got different slopes. This slope up here would be 0. Then we've got negative slopes, yes? So notice here it says when thinking about slopes, marginal cost is less than marginal revenue. They make more in extra revenue than it will spend in extra cost by increasing production. So marginal cost less than marginal revenue. I'm trying to think. So marginal cost is always this one. Marginal revenue is my parabola. So how am I supposed to focus with that going on out there?
You don't.
Sorry, I really am trying to tune them out, and my brain is not working here for it. Right here, we have this slope that's, I don't know, 1/2 or so. Here, these slopes are going to be steeper, so that's going to be my marginal revenue is going to be bigger. So you're talking right there. Here, am I guessing that that is the change point? Or am I wrong? I feel like it's not going to happen to more like up there. Is when we're going to change and the slope's going to change there. Because that's always going to be a positive slope. Whereas over here, we're going to start getting a negative slope. Okay? So it's going to be almost up at that point before you change over from where marginal cost is no longer less than marginal revenue. Okay? So, trying to think, have I hit on everything? Have I hit on my notes? I think I have. We'll find out as we go if I have to come back, right? Okay, 2 pages. Can I make it happen? Maybe. I was not here to count me my pages.
No. It's okay though.
Okay.
We've gone for 2.5 so far, or 1.5 so far. So
An office supply manufacturer produces spiral notebooks for interactive student notebooks. Find the quantity X that maximizes profit if the total revenue R of X and the total cost C of X are given in dollars by these equations. When X is between 0 and 1,000 notebooks, what production level gives the maximum profit?
And
Okay.
instead to just put the derivatives, like take the derivatives and then set them equal to each other. So that's what we're doing.
Yep, because I just say they've asked the same question twice, haven't they? Find the quantity X that maximizes the profit. Oh, and then they give us a specific number, don't they? Well, but it's still what production level gives the maximum profit. Okay, so when we talked max profit on the previous page, we talked about marginal revenue equaling marginal cost, right? So we need to first of all find marginal revenue. No, I don't want pi of x right now. Well, I guess we could. Not the way I was thinking about it. Marginal revenue is going to be r prime of x. What's r prime of x? 8 minus 8 thousandths x. marginal cost. So C prime of X is
1.2.
1.2. And in order to maximize profit, we want to find where MR equals MC. That is your max profit is going to happen at that point. So set your equations equal to each other. Eight minus 800's X equals 1.2. I'm going to keep the negative 8,000's X, excuse me. 1.2 minus 8 is going to be negative 6.8 if I've done my math right.
Yeah.
The calculator is going to do the next step for me because I'm not doing it. 850? I can't say it right. Okay. So what is happening at 850? This is where your max profit happens. Okay. Now, that answers the question, doesn't it? Where X is between 0 and 1,000 notebooks, what production level gives the max profit? We have it. Okay. Now,
No, it's quantity.
do I want to go through a check? I have a check over in my margin, but
You said don't. Okay. I was like, yes, Mario was wrong.
We said this.
I heard dollars, so.
okay. I'm just going to leave it here because I know we're going to end up running out of time if I'm not careful. So I have off to the side where I went through a check, looking at the marginal revenue at each one, finding profit and all of that. But we're just going to stop here. So this would be 850 notebooks, right? So I'm going to leave it there. I could go into a lot more, but I'm not going to because I want to get ahead of us, not behind us. Okay, 6. Table below shows cost and revenue for the production of a widget. Use the table to answer the following questions. So, technically, I've always thought of a widget as so before phones were a big thing, I've always thought of a widget as just a fictional item that is in math problems. I don't know if it's always been something. Yeah, now it's like the widgets on your phone type thing, but I don't know if it's always been something or not. Because the word widget in math problems has been around a lot longer than cell phones been around. Okay. With this in mind, what is the price of the widget?
$600?
No.
Do we have to find
No.
in between 0 and 200 since there's not the price of one?
Yeah, probably.
Well, no.
Oh, why?
Okay.
I'm
So,
just confused why it costs money.
Okay.
Equals 300. RX equals 300x.
Because they lose.
so what does X stand for here?
Oh wait, that's 3x.
How many are made?
Okay. So X, that is the number that are made, right? So this is when 0 are made, 200 are made, 400, 600, 800, 1,000 are made. Yes? Okay. What's R of X stand for?
It's for every quantity made.
The revenue.
Yeah.
So if we sell each of these amounts, how much we bring in? Yes?
Yep.
And what's C of X stand for?
Cost.
The cost. So the cost of how much it takes to make each of these amounts. So how can we find the price of one singular widget?
So R of X equals 3X, and C of X equals. Because.
Don't try to write an equation, just,
Oh, you're not trying to.
no, I'm not trying, I just wanna know what's the price of a widget.
$3. 100.
$3.
Oh, I was gonna say 300.
$3.
Why is it 3?
60 divided.
why would it be
Oh my
300?
gosh.
Wait, what did you say? 600 divided by 200.
That's what I was trying to do.
makes
That's
Or-
what I did in my head.
1,200 divided by 400, or 1,800 divided by 600, or 2,400 divided by 800, or 3,000 divided by 1,000. So the idea is to get the price of one widget, take your revenue, and divide it by its equivalent to X. Does that make sense? The revenue at a certain level divided by how many were sold, and any way you slice it, you're going to get 3. So that is a price of $3. Okay. What are the fixed costs?
What is that?
800.
Explain.
Because even at 0, it still costs 800. So it has to be 800 for the fix.
Your fixed costs are, those costs exist no matter what. So to sell one widget, to produce one widget, forget the word sell, to produce one widget, it's going to cost me $800. Okay.
Why the heck are they selling for $3 then?
They're still going to make money if you look.
How?
Because they're selling for $3, that $3 will get covered. Okay? Now, can you just sell one widget and make money? No. Can you just sell 5 widgets and make money?
No.
No. So,
Don't break even until 400. You have to sell 400.
I know, I was looking to see if C was asking about break even, because we need to talk about break even. What do we mean break even here?
Whenever they,
When
We make the money.
they're not
You
making
don't
money and they're not losing money.
And so do you see why that happens at 400? That is my break even point. When I sell 400 widgets, I'm going to bring in $1,200, but it will have cost me $1,200. So in order to make a profit, I have to sell 401 widgets. And then I'm not sure it's worth it for the profit at that point, but you gotta sell a little bit more than 401. Okay? Now, at what production level, X, is the profit for the widget maximized?
Ooh, that's 0.
Something.
The derivative of something.
But we don't have an equation here.
You're right. I was looking at the equations up there.
Revenue minus cost.
Okay? So, in order to find, how do we find profit? Profit is revenue minus cost, yes? When is the profit maximized? This is what I was just looking.
Well, you know it's past 400.
Okay? Before 400, we're not even making a profit. And at this point, I think it's just an eyeball game. I don't have a way I solve this. And when I say an eyeball game, what are we going to be comparing?
Those two.
Those two.
I'm guessing.
I'm not even going to look over here, am I?
No.
Okay. Where's going to be our biggest difference?
800. No.
Can we just subtract the
Uh-huh.
cost of the?
If we, I say, I think 1,000, isn't it?
Yeah, because with 800.
Because what is R of 1,000 minus C of 1,000? And that is, let's see, is that 1,150? Okay, so the cost at 1,000 widgets is 1,050. Do I have anything bigger than that on this chart? No. Okay. That's closer to 1,000. That's less than 1,000. So that is your biggest thing. Now, I don't have a way to do that other than eyeballing it. Ah. Here's where I need to go back. Oh, I did just catch a note. Okay, wait. I'm going back to somewhere. Where did I see it? Somewhere something was mentioned about endpoints. Oh, that's right. Okay. So, it was the pretty picture on 221. Maximum or minimum profits do not necessarily have to occur where MR equals MC. They can also occur at endpoints. And so right there, when we look at endpoints, that's going to be our biggest endpoint there. Okay? So that is keeping in mind that endpoint comment from the previous page. Okay? Maximum profit occurs when production is 1,000 widgets. Do I need to write that out? I guess it does, doesn't it? Maximum profit occurs when (1,000) widgets are produced. Actually, I should say produced and sold. Just producing them isn't going to give me a max profit. And then, yeah. I don't really, other than that, I just have what we already have here, that the pi of 1,000 is R of 1,000 minus C of 1,000. So. Okay, 7. When a backpack production is $5,000, marginal revenue is $5 per backpack, and marginal cost is $4.65 per backpack. Why do I have a question mark on this one? Sorry, as I started reading this one, I have a question mark, I realized. Is that because I skipped it? We have something like this in homework? Maybe that's why I took it out? I don't remember at this point. Okay, you know what? We're going to skip this one for the moment. Obviously, I will come back to it tomorrow if I need to, right?
Yep.
Gaby.
Yeah.
I don't know.
Gaby.
I know.
Okay,
Mostly.
skipping for the moment. Or if we have time. Can we not spell Gabby a different way, I take it?
Well, the only Gabby's I know for 2 weeks.
What? I've seen it like this.
I've no
I can't say I've seen it like this other than here, but. Okay,
Maybe she's a widget.
Gabby is working on a project that watches the decline in great white sharks in the Atlantic Ocean. The given function, S of t, gives the number of sharks t years since she began working on the project. Find the rate of change to the number of sharks in the ocean after 3 years. Okay. Find the rate of change, which is derivative. Specifically then after 3 years, so that will be okay.
Oh, never mind.
So derivative. Let's practice our derivative rules here. Derivative of e to some power.
Use
E to
some
some power.
So, whoops. 3570 e to the negative 2/10. Negative 2/10 t
power.
Some power.
times the derivative of said power.
Negative 0.02.
Derivative of negative 2/10 t is negative 2/10. Now, if I clean this up, how can I clean this up?
Multiply the 2/10 to 3570.
Yeah, the 3570 times negative 2/10 can be multiplied because that 3570 is just a coefficient. So that's going to be negative something. Whatever 2 times
Negative
357 is.
Negative 714.
So negative 714 e to the negative 2/10 power. We want the rate of change to the number of sharks in the ocean after 3 years. So S prime of 3. This is definitely a calculator plug-in, isn't it? What is 3 when you plug it into that lovely little equation?
gosh, offline.
Is it with the caret button? Nope, that's pi.
So it's second.
It's on the LN button. It's on the LN button, that's one I use. There's also an E over the division button.
Wow.
I use the E to a power though.
Is it negative 13,000?
I got negative 391.
Oh, okay.
391. Yeah. Not
I definitely got negative 13,000.
you definitely got wrong.
Is it because?
You definitely played something in wrong.
0.8.
You probably
I didn't do a negative on the. There we go.
On the exponent. That makes a big difference. Okay, negative
No, it
391 what?
0.85.
There we go.
8.92. It's almost like having 2 years.
852 is traditional rounding. Truncating is 851, and that is acceptable by AP standards. So 851, 852. Now, regardless, what is this saying?
That they're diminishing by that many sharks per year.
After how many years?
3 years.
After 3 years. Yep. So
That's a bad idea.
the shark population,
Average strikes 3 years.
I'm going to say, is decreasing. Doug got fancy and said diminishing, but I don't want to spell that, so I'm going to go with decreasing.
D-I-M-I-N-I-S-H.
At a rate of, in my notes, I actually wrote of about 392. I think it probably did that because we're talking about a population, but officially, unless you're given information, we should probably use a whole number, or the exact number, decimal number. 391.852 sharks per year after 3 years.
So the unit
Oh my
of
God.
sharks and bloops.
I didn't need to know this.
About
Omar.
Okay, Omar. Sophie does not want to know about Omar. Let's read about Omar. Omar uploaded a funny video of sugar gliders on his Instagram account. The video went viral rapidly. The number of views T-days after Omar uploaded the video can be modeled by this function V of T. What is the instantaneous rate of change of the number of views 5 days after he uploaded his video?
Is it not the same thing?
No, speed of rate of change.
Well, what's instantaneous rate of change mean?
At that moment,
Mm-hmm.
not over.
So, V prime of T? In all honesty, are they asking what is V prime of T? No, they're just asking for instantaneous rate of change 5 days after he uploaded his video. Could you just go straight to the calculator if it's a calculator problem?
Yes.
You could. Okay. So, let's see. This derivative is going to be 243 e to the 5/10 t, and then times 5/10. So then half of 243 is 121.5 e to the 5/10 t. If I plug 5 in, we're going to have well, my notes say 1,480.173.
It's not.
So, what are we saying? After 5 days, what do we know? Omar's videos are doing what?
Increases.
Or actually, it's video views are increasing. And they are increasing at a rate of,
1480.
yeah, And if I say of about 1,480 views per day. Okay, 10. Yeah, I probably should have skipped 9 and gone to 10 now that I look at it, but let's see what we can talk about with 10. 10 is everyone's favorite topic. Okay, maybe only 2 people's favorite topic.
Water.
Eh. Oh, wait, I saw V and thought we were going to velocity. We're not. Okay.
No.
Use the following table of values for the number V of T gallons of water in thousands per hour H that are flowing into a retention pond T hours after a severe thunderstorm.
I dug everything.
Okay, now, what is the interpretation of V prime of T? Not find it, but what is the interpretation?
It's the gallons of water per hour.
The rate.
Um,
The rate. Rate.
Okay,
The rate of that.
so some type of rate of change here. V prime of T, you can say the instantaneous rate of change of the, now, you said gallons of water. Officially, I'm going to say thousands of gallons of water because
It's 1,000.
it's in thousands. Okay. Per hour after T hours, and that's flowing into the retention pond. So, V prime of T is the instantaneous.
I'm just putting
That would have been smart. Instantaneous rate of change of thousands of gallons of water
Too many gallons.
per hour after T hours. Flowing into retention pond. Okay. Estimate V prime of 2. Options. How could I find V prime of 2?
Give you the 2.5 to 1.5.
I would say yes. I'm looking at what my options are I have listed here. Okay, so actually, because 2 is listed, see, it's the thing. So often we've done these where 2 is not listed, right? So we do what's on either side. Because 2 is listed, you would actually want to use 2. So you either want to use 1.5 and 2 or 2.5 and 2. Okay? So either way, you guys got a preference?
No.
V of 2.5 minus V of 2. And that's going to be divided by 2.5 minus 2. Which?
0.9 over 0.5.
1.24 minus 1.15 is what I was saying. Over the 2.5 minus 2. I just have that it comes up to be an answer of
0.8.
0.18 is what I have.
Oh, that's
Okay? Okay.
0.09.
Yeah. So we got almost everything done. I'm looking to see, we've talked about that one. When does the rainwater flow begin to slow down? Estimate the instantaneous rate of change for this time. And that would be looking,
Grade 3.5.
increasing,
Between 3.
right there, yes. Okay, that would be where it would start slowing down. Okay, guys, we got through most everything. We did good. 4.3 homework. Do it. I will get the answer key posted. And we'll go from there.